Are we alone in the universe? Is a question as old as human curiosity itself. Long before telescopes, rockets, and satellites, humanity stood beneath the night sky and wondered about the lights scattered across the heavens. To ancient eyes, those stars were not just distant suns, but living beings, gods, or realms of spirits. The universe was alive with mystery, and people imagined otherworldly neighbors looking back at us. In ancient Babylon, priests charted the stars and believed the heavens influenced human destiny. The Greeks told stories of gods and heroes who ascended into the skies. Indian and Chinese philosophers speculated that the cosmos was infinite, perhaps even populated with countless worlds. And in the Islamic Golden Age, thinkers like Al-Farabi and Ibn Sina debated whether stars might host their own planets. The human imagination has always been fertile ground for alien life. Myths spoke of gods descending from the heavens, chariots of fire, and creatures not of this earth. Even then, the seeds of the question were planted. If there are so many stars, could there also be other forms of life? The age of telescopes, the first real glimpse. Fast forward to the Renaissance. In 1609, Galileo Galilei turned his telescope toward the heavens and shattered old beliefs. He saw craters on the moon, moons orbiting Jupiter, and countless stars invisible to the naked eye. Suddenly, the universe wasn't just a backdrop, it was a stage filled with worlds. It didn't take long for dreamers and scientists to wonder whether these worlds were inhabited. By the 19th century, astronomers studying Mars believed they saw canals crisscrossing its surface. An Italian astronomer, Giovanni Schiaparelli, described them as canali, meaning channels. English speakers mistranslated this as canals, and the world erupted with excitement. Newspapers speculated about Martians building waterways to survive on a dying planet. Science fiction writers fueled the fire. H.G. Wells wrote The War of the Worlds in 1898, where Martians invade Earth with terrifying machines. For many, it wasn't just fiction, it was a genuine possibility. The idea that intelligent aliens might live next door captured the public's imagination. Some believed the moon might host forests, Mars might have deserts filled with life, and Venus, with its thick clouds, might be a jungle world. Humanity's early imagination projected Earth's conditions onto other planets, assuming life must exist everywhere. The rise of science fiction and real science. By the early 20th century, science fiction and science itself were intertwined. Writers like Jules Verne, H.G. Wells, and later Arthur C. Clarke and Isaac Asimov painted vivid pictures of alien civilizations, space travel, and interplanetary wars. These stories were not mere entertainment, they inspired real scientists and engineers. Think about it, how many rocket scientists grew up reading pulp magazines filled with alien encounters? Fiction pushed science forward by making humanity believe that not only could life exist elsewhere, but one day we might meet it. But as our technology advanced, so did our sobering realization. The first robotic probes sent to the moon and nearby planets showed barren, lifeless landscapes. Venus, once thought of as Earth's twin, turned out to be a hellish furnace with crushing pressure and toxic clouds. The moon, a dusty, airless desert. For a time, it seemed that perhaps Earth really was unique, a rare oasis in a cosmic wasteland. Mars, the red hope. And yet one planet has always remained at the center of the search, Mars. Unlike the moon, Mars held on to a few tantalizing clues. In 1976, NASA's Viking landers touched down on the Martian soil, armed with experiments to detect life. For a brief, electrifying moment, one of the experiments gave results that looked like signs of microbial activity. Scientists debated furiously. Was it real life, or just unusual chemistry? To this day, the results remain controversial. But the real evidence came not from biology, but geology. Orbiters mapped ancient river valleys and dry lake beds carved into the Martian surface. Rovers like Spirit, Opportunity, and later Curiosity discovered minerals that could only form in water. Mars once had oceans, perhaps even a climate similar to early Earth. And where there was water, there may have been life. Maybe not little green men with ray guns, but tiny microbes clinging to survival in shallow seas billions of years ago. Even now, traces of methane in the Martian atmosphere tease us, methane that could be produced by geological activity or by life. Lessons from the moon, a sterile neighbor. Before Mars, humanity turned first to the moon. Apollo astronauts in the 1960s and 70s brought back rocks and soil for analysis. What they found was disappointing for those hoping for alien microbes: sterile dust, no water, no organic compounds, nothing alive. The moon was lifeless. But this wasn't a failure. It was a vital lesson. If life exists elsewhere, it cannot be assumed. It must be searched for carefully, with evidence, not imagination. The moon also served as a stepping stone. By proving lifeless, it forced us to look outward, beyond Earth's backyard, to more promising worlds. A transition of hope. By the end of the 20th century, humanity stood at a crossroads. We had dreamed of Martians and moon creatures, only to find barren deserts. But in that disappointment, we discovered something extraordinary. The conditions for life are more complex than we imagined, but not impossible. Mars still held mysteries. Venus, though deadly, might have strange microbes floating in its upper atmosphere. And far beyond the asteroid belt, icy moons shimmered with hidden oceans beneath their frozen crusts. The search for alien life had not ended. It had just begun to evolve. If the moon was sterile and Mars only whispered of a watery past, then perhaps the answer to alien life lies deeper, in the shadows of icy worlds where oceans hide beneath the ice. If there's one lesson Earth has taught us about life, it is this: where water flows, life follows. From the lush rainforests to the frozen tundras, from the surface of the oceans to the darkest, crushing depths, life has carved out a place for itself. Microbes thrive in boiling hot springs, bacteria survive in acidic pools, and strange creatures glow in the blackness of the deep sea. Life, it seems, is astonishingly resilient. So if we are searching for alien life, the best place to look may not be the rocky surface of a planet, but beneath layers of ice, where oceans lie hidden, protected from deadly radiation and cosmic storms. And in our solar system, such hidden oceans are not rare. They might be the most common habitats for life beyond Earth. Europa, the shining jewel of Jupiter. Orbiting the giant planet Jupiter, Europa looks at first like a simple ice ball, a world coated in brilliant white frost. But a closer look reveals something extraordinary. Its surface is crisscrossed with cracks, ridges, and reddish-brown streaks. These scars tell a story. The ice is not solid rock, but a shifting shell, floating atop a vast subsurface ocean. Scientists believe Europa's ocean may contain more water than all of Earth's oceans combined. Imagine that, an alien sea larger than every ocean on our planet, hidden beneath just a few kilometers of ice. What makes Europa even more fascinating is heat. Despite being far from the sun, tidal forces from Jupiter's immense gravity need the moon's interior, generating warmth. This heating could keep the ocean liquid for billions of years, creating an environment potentially stable enough for life. On Earth, deep-sea hydrothermal vents support entire ecosystems without sunlight. Giant tube worms, blind crabs, and shimmering bacteria thrive by feeding on minerals and chemical energy. If such life can exist here, why not on Europa, where similar hydrothermal vents may line the ocean floor? The possibility is so strong that NASA is planning the Europa Clipper mission, a spacecraft designed to fly past Europa dozens of times in the 2030s. It will search for chemical signs of life, map the icy crust, and even sniff the thin atmosphere for water vapor plumes erupting through cracks in the ice. If Europa harbors even microbial life, it would be one of the greatest discoveries in human history, a second Genesis, proving life is not unique to Earth. Enceladus, the cryovolcanic world of Saturn. If Europa is mysterious, Enceladus is spectacular. A tiny moon orbiting Saturn, only about 500 kilometers across, Enceladus astonished scientists in 2005 when NASA's Cassini spacecraft flew by and captured something extraordinary: massive geysers shooting out from its south pole. These plumes of water vapor and ice crystals sprayed into space like cosmic fountains. Cassini flew through them, and what it found was breathtaking. The plumes contain water, salts, and complex organic molecules, the building blocks of life. This was not speculation. This was direct sampling of material from an alien ocean. Beneath Enceladus's icy crust lies a global ocean, kept warm by tidal heating. And like Europa, it may host hydrothermal vents on the ocean floor, where life could thrive. Scientists now consider Enceladus one of the best candidates for extraterrestrial life in the solar system. And unlike Europa, where the ocean is locked under thick ice, Enceladus conveniently spits its water into space for us to analyze. It's as if the little moon is offering samples to anyone willing to catch them. Future missions may send probes specifically to fly through these geysers again, this time with instruments designed to detect not just organic molecules, but potential biosignatures, chemicals that could only be explained by biology. Titan, the methane mystery. Another of Saturn's moons, Titan, presents a stranger case. Larger than Mercury, Titan is the only moon in the solar system with a thick atmosphere. Its skies are filled with orange smog, and its surface is dotted with rivers and lakes, not of water, but of liquid methane and ethane. To us, Titan seems alien and inhospitable. Water is frozen as hard as rock, and the temperature is hundreds of degrees below zero. Yet some scientists speculate that Titan could host a different kind of life not based on water, but on methane chemistry. This would be life as we cannot imagine it, organisms using methane the way Earth's life uses water, with membranes and cell structures made of completely different molecules. If such life exists, it would prove that the universe doesn't just repeat Earth's pattern of biology, but invents new ones. NASA's upcoming Dragonfly mission will send a drone-like rotorcraft to Titan in the 2030s, hopping across its alien landscape and studying its chemistry. If Dragonfly finds even a hint of prebiotic chemistry or exotic life, it would change our understanding of what is possible. Other icy worlds. Beyond Europa, Enceladus, and Titan, several other moons in the solar system may also conceal oceans. Ganymede, the largest moon in the solar system, is believed to have a deep ocean sandwiched between layers of ice. Callisto, another Jovian moon, may harbor salty water beneath its crust. Even Pluto, once considered a frozen dead rock, might hold an underground ocean beneath its heart-shaped ice plains. The more we look, the more it seems that hidden oceans are everywhere. Far from being rare, watery worlds might be the rule rather than the exception. A new philosophy, life in the shadows. For centuries, humans expected alien life to be found on the surfaces of planets, forests on Mars, swamps on Venus, civilizations under strange suns. But the icy moons have rewritten that story. Life, if it exists, may not bask under alien skies. It may thrive in the dark, silent oceans beneath ice shells, warmed by geothermal heat, invisible from space. And if life can flourish in such hidden places, then the galaxy may be teeming with it. Perhaps the universe's most vibrant ecosystems lie not on sunny Earth-like planets, but in secret oceans, sealed away in ice, waiting for us to discover them. For most of human history, the stars were unchanging points of light, eternal and unreachable. We wondered if they were gods, fires, or crystal lamps hung on the vault of heaven. Even when science revealed them as distant suns, the question remained, did they host planets like our own? And if so, could life exist there? For centuries we had no answer. Planets around other stars were invisible to our telescopes. The dream of other Earths was confined to imagination and science fiction. Writers like Olaf Stapledon, Arthur C. Clarke, and Isaac Asimov populated the galaxy with alien worlds, but they could not prove they existed. Scientists suspected planets must orbit other stars, but until the late 20th century, no one had ever seen one. That changed in 1992, when astronomers Alexander Woolsey and Dale Frail made a startling discovery. Tiny shifts in the radio pulses of a neutron star revealed the presence of two planets orbiting it. These were the first confirmed exoplanets, planets beyond our solar system. They were not habitable, orbiting a dead pulsar, but their discovery opened the floodgates. Just 3 years later, in 1995, Michel Mayor and Didier Queloz detected 51 Pegasi b, the first planet discovered around a sun-like star. It was a hot Jupiter, a gas giant orbiting dangerously close to its star. No one expected such a planet could exist, but it shattered assumptions. The universe was stranger than we imagined. The exoplanet revolution. From those first discoveries, the pace accelerated. The real revolution came in 2009, when NASA launched the Kepler Space Telescope. Kepler stared at a patch of sky for years, watching over 150,000 stars, waiting for the tiny dimming that occurs when a planet crosses in front of its star. The results were astonishing. Within a decade, Kepler discovered thousands of planets, revealing a galaxy teeming with worlds. Today, astronomers have confirmed over 5,000 exoplanets, with thousands more candidates waiting to be verified. We now know that planets are not rare, they are everywhere. On average, every star in the Milky Way likely hosts at least one planet. That means our galaxy alone may contain over 100 billion planets. With hundreds of billions of galaxies in the universe, the numbers are beyond comprehension. The discovery of exoplanets transformed the search for alien life from a dream into a scientific endeavor. For the first time, we could identify actual targets, real planets orbiting real stars that might host life. The habitable zone, the Goldilocks principle. Not all planets are created equal. Gas giants may be spectacular, but they cannot host life as we know it. What we seek are rocky, Earth-sized planets in the habitable zone, the region around a star where conditions are just right for liquid water to exist. Too close to the star and water boils away. Too far and it freezes. But in the sweet spot, oceans could form, climates could stabilize, and biology could thrive. This is sometimes called the Goldilocks zone, not too hot, not too cold, but just right. Kepler's discoveries show that many stars have planets in their habitable zones. Some systems even have multiple potentially habitable worlds. If water and the right chemistry are common, then the conditions for life could be widespread. Famous exoplanets, Earth's distant cousins. Among the thousands of exoplanets, a few stand out as tantalizing candidates for habitability. Kepler 452b, nicknamed Earth 2.0, this planet orbits a sun-like star about 1,400 light-years away. It is larger than Earth, possibly rocky, and sits squarely in the habitable zone. Its discovery was hailed as a milestone, a planet that might look very much like home. Proxima Centauri b, orbiting the closest star to our solar system, just 4.2 light-years away. Proxima b is an Earth-sized planet in the habitable zone. While its star is a volatile red dwarf, blasting radiation, Proxima b remains our closest chance to study a potentially habitable world. The TRAPPIST-1 system. In 2017, astronomers announced a breathtaking discovery: 7 Earth-sized planets orbiting a single star, with at least 3 in the habitable zone. This compact solar system, just 40 light-years away, has become a prime target in the search for life. These are just the highlights. From water-rich super-Earths to exotic worlds with iron rain, the diversity of planets is staggering. Some hug their stars so tightly that a year lasts only days. Others drift in eternal darkness, rogue planets, wandering the galaxy without a sun. Each discovery expands our definition of what a planet can be. Beyond Earth-like, life in strange places. While a habitable zone is a useful guide, scientists now realize life may exist in far stranger environments. After all, we found potential habitability in the icy moons of our own solar system, worlds far beyond the sun's warmth. Similarly, some exoplanets outside the traditional habitable zone might still sustain life. Planets with thick atmospheres could trap heat and maintain oceans even at greater distances. Others orbiting red dwarfs may be tidally locked, with one side facing eternal day and the other eternal night, yet with habitable twilight zones in between. Some scientists even speculate about exotic life forms, organisms that breathe methane, live in liquid nitrogen, or use silicon instead of carbon as the backbone of their chemistry. If nature is inventive on Earth, why not elsewhere? We began by dreaming of Earth-like twins. But the more we look, the more we realize that life may not be limited to Earth's recipe. The universe could be filled with possibilities stranger and richer than we ever imagined. We have mapped the icy moons. We have cataloged thousands of exoplanets. We have peered into the atmospheres of distant worlds. And yet, the greatest question still hangs over us like a shadow. If life is common, why haven't we found it? On paper, the universe should be overflowing with civilizations. With billions of stars in the Milky Way, each with planets and billions of galaxies beyond, the odds seem overwhelming. Even if life arises only rarely, the numbers suggest countless alien civilizations should be out there. So where are they? This paradox, so simple yet so haunting, is known as the Fermi paradox, named after physicist Enrico Fermi, who famously asked during a lunch conversation in 1950, "Where is everybody?" The Fermi paradox, a cosmic puzzle. The paradox arises from 2 conflicting truths. 1. The universe is vast and ancient. There are perhaps 100 billion stars in the Milky Way alone, most older than our Sun. Many have planets in the habitable zone. If intelligent life develops, some civilizations should be millions of years ahead of us. 2. The universe is silent. Despite decades of searching, we have detected no unambiguous signals, no alien probes, no undeniable evidence of extraterrestrial intelligence. This silence forces us to consider unsettling possibilities. Possible explanations. Why haven't we found them? 1. Life is rare. Perhaps the leap from chemistry to biology is incredibly unlikely. Maybe Earth is one of the few places in the universe where life managed to emerge at all. 2. Intelligence is rare. Microbial life might be common, but intelligent, technological civilizations may be vanishingly rare. Dinosaurs ruled Earth for 160 million years without developing radio telescopes. Intelligence might be an evolutionary accident, not an inevitability. 3. Civilizations self-destruct. Even if intelligence arises, perhaps it doesn't last. Civilizations may destroy themselves through war, environmental collapse, or technology before they can colonize the stars. In this view, we might be hearing only the echoes of civilizations already gone. For they're hiding. Maybe advanced civilizations choose not to reveal themselves. They could be practicing a kind of galactic prime directive, observing us but never interfering. Some call this the zoo hypothesis. We are animals in a cosmic preserve, watched but never contacted. 5. We're not listening the right way. Perhaps alien communication doesn't come in radio waves at all. Maybe they use technologies we cannot yet imagine, neutrino signals, gravitational waves, or quantum entanglement. If so, our telescopes are like cavemen trying to pick up Wi-Fi with sticks. 6. They're already here. A more speculative possibility is that aliens have already visited, but we fail to recognize them, or their probes are too small, too advanced, or too well hidden to detect. Each explanation is unsettling in its own way. Either we are unique, which makes life unimaginably rare, or civilizations are everywhere, and for some reason, none have spoken to us. SETI, the hunt for alien signals. Despite the silence, humanity has not stopped listening. Since the 1960s, projects like SETI, Search for Extraterrestrial Intelligence, have scanned the skies with giant radio telescopes, searching for patterns amid the cosmic static. In 1977, astronomers detected the famous WOW signal, a strong, unexplained burst of radio waves that lasted 72 seconds. It came from deep space, near the constellation Sagittarius. No one has ever explained it, and it has never repeated. Was it a technical glitch, a natural phenomenon, or a brief hello from a distant civilization? We may never know. In 1974, astronomers even sent out a message, the Arecibo message, a broadcast of binary code encoded with information about humanity, our DNA, and our solar system. It was aimed at a cluster of stars 25,000 light-years away. If anyone out there is listening, they won't hear it for another 25 millennia. SETI today uses not just radio but also optical telescopes, scanning for laser pulses and unusual energy signatures. Artificial intelligence now helps sift through the torrents of data, hunting for the faintest whisper of alien technology. Technosignatures and megastructures. Recently, scientists have expanded their search beyond radio. They now speak of technosignatures, any observable evidence of technology. This could include unusual atmospheric gases like industrial pollution, planetary night sides lit up with artificial lights, strange energy patterns around stars, perhaps evidence of massive structures. One famous case involved Tabby's star, which dimmed unpredictably in a way that led some to speculate about a Dyson sphere, a hypothetical megastructure that could capture a star's energy. Though natural explanations seem more likely, the fact that such possibilities are even considered shows how far the search has come. The silence of the stars does not mean we are alone. It may mean we are still deaf, still young, still searching with crude tools in a universe that speaks in languages we have yet to learn.